Well, I'm glad you're back. We're going to be looking at some problems this time relating to molarity and stoichiometry. So this is the chemistry, the math of the solutions unit, as well as we'll look at a limiting reactant problem. So hopefully this will be helpful for you as we go through some of these problems. So in the first question, and we'll just look at some simple ones here, how many grams of copper are required to react with 1.5 liters of 0.1 molar silver nitrate? So we'll start with a balanced chemical equation. So it says here how many grams of copper are required to react with the silver nitrate. So I got copper plus silver nitrate. Then I would have to recognize this is a single replacement reaction. So the copper is going to replace the silver, and this because copper is more chemically reactive if I use the activity series. Silver precipitates out, and the copper goes back into solution with the nitrate floating around. So we've also balanced it, so that makes it a little bit quicker, a little bit easier for us. So now let's see what we would do. Okay, we've added some information. We're trying to find the grams of copper, and we're given information, molarity and a volume. In essence, molarity and volume, this is moles. So we're really given the moles, although it's disguised. So this is really a mole to gram calculation. So let's fill it in here. We have 1.5 liters of this solution, and we know that 1 liter of this solution is 0.1 molar because it says here the concentration is it's 0.1 molar. Molarity is, recall, moles per liters. What happens to the unit liters? Well, it cancels like that. Now, if we stop now, we're at units of moles of silver nitrate, and we're trying to get to grams of copper, so we're not yet done. What do you think we'd have to do now? How would we go from, I don't know, moles of silver nitrate into, I hope you're thinking, moles of copper? If you said use those coefficients from the balanced chemical equation, you're thinking correct. So what's going to go down here? I think I heard you say 2 moles of silver nitrate, and then you want to put 1 mole of copper up here. That's right. 2 moles of silver nitrate, 1 mole of copper. We get that again right from here, the coefficients. 2 moles of silver nitrate, 1 mole of copper. Look at what happens to our moles of silver nitrate unit. Like that. Now we have moles of copper, and we're trying to get to grams. Well, that should be a pretty easy conversion. I just look at my periodic table. I find copper up there, and it says that 1 mole of copper is about 63.5 grams. Notice my moles of copper now cancel like that. I punch this into my calculator. I must be faster than you because I have my answer, 4.8 grams of copper. Hopefully you will get that answer as well. Let's try another one. Here we have an equation. Zinc plus hydrochloric acid produces zinc chloride plus hydrogen gas. I've already balanced it for you. Now we're given some information here. It says 79.1 grams of zinc react with 0.9 liters of 2.5 molar HCl. In essence, this is the number of moles of HCl that I have. So I have to identify the limiting and excess reactant here. And once I do that, I'll be able to answer the question, how many liters of hydrogen gas would be formed using this setup at standard temperature and pressure. So I want to find out the number of liters of hydrogen gas I would produce if I start with 79.1 grams of zinc, and I have 0.9 liters, that's 900 milliliters, of 2.5 molar solution. Okay, so let me give myself a little space here. We're going to set this up. I have 79.1 grams of zinc, and using the periodic table, I find that 65.4 grams of zinc is 1 mole, so that grams of zinc cancel, like that. Once I get moles of zinc, I can go to moles of HCl. I will, of course, be using the coefficient, 1 mole of zinc, 2 moles of HCl. So 1 mole of zinc, 1 mole of hydrogen. Well, I guess I don't need that because I'm trying to figure out the volume of hydrogen, aren't I? Guess if I would read the question more carefully, we would have known that. So 1 mole of zinc, 1 mole of hydrogen. And those moles of zinc cancel. And finally, because this is at STP, 1 mole of hydrogen, 22.4 liters. That gives me an answer of 27.1 liters of hydrogen. I'm going to remember that. Now I'm going to rework the question, starting with my acid information and seeing what volume I get. So I have 0.9 liters of HCl. 1 liter is 2.5 molar because the molarity is 2.5, which means 2.5 moles of HCl per 1 liter. Liters cancel, like that. Now I'm going to go ahead and use the coefficients. 2 moles of HCl, 1 mole of hydrogen. Moles of HCl cancel, like that. And finally, I'm at moles of hydrogen. I know that 1 mole of any gas, such as hydrogen, would occupy 22.4 liters at STP. So moles of hydrogen cancel, like that. And I get an answer of 25 liters. Now, in the first case, I said I would have produced 27.1 liters. In the second case, I'd get 25 liters if I start with the HCl. The answer is always whichever one provides or makes less product, that's your limiting reactant. So in this case, the limiting reactant is HCl, hydrochloric acid. The excess is obviously zinc, and so I would only form 25 liters of hydrogen. And then there'd be just a little bit of zinc left over right in the bottom of the beaker. Okay? All right, I hope this was helpful. Here's just a few rules. I'm not going to read them to you, but you can kind of see some general ideas when solving one of these problems. You would probably want to hit pause as I'm going to stop very shortly. All right, have a great evening doing your chemistry. Bye-bye.